I need this idea of absolutely convergent to help me with the ratio test. So the ratio test says that if I have the limit as n goes to infinity of a subsequent term divided by a term, the absolute value of that, if that ratio is less than 1, then the sum of my sequence will be absolutely convergent. Greater than 1, divergent. Exactly equal to 1, it's inconclusive and we have to use another test. Ratio test is great anytime I have functions that might need to cancel. So anytime I have exponentials, factorials, those are when I'm going to think of using ratio test. Also, if I have something alternating, but I can't prove that this is decreasing or that the limit of this goes to 0, then I'll want to look at ratio test. And even if I don't want to prove that it's decreasing, ratio test gives me another really nice way to look at it. So I'm going to start with limit as n goes to infinity, absolute value. I'm going to do n plus 1, so -1 to the n plus 1, n plus 1 cubed over 3 to the n plus 1. Instead of dividing by this fraction, I'm going to multiply by its reciprocal. So that's going to be 3 to the n on top over -1 to the n times n cubed. Now if I simplify my n plus 1 and n, that's just going to leave me with a -1. Absolute value of -1, though, will be positive. 3 to the n over 3 to the n plus 1, well, that's going to leave me a 3 in my denominator. So I'm going to have limit as n goes to infinity. So I could still think of that -1 up top, my 3 in the denominator. Also up top, I've got my n plus 1 cubed. So that's going to be n cubed, 3n squared, 3n plus 1. In my denominator, I've just got n cubed. So limit as n goes to infinity, well, this whole function is going to go to 1, so I'll end up with 1/3, which is less than 1. Therefore, my sum, -1 to the n cubed over 3 to the n, converges by ratio test.